imagine the center of this circle is here, then the radius of the circle is any line that can be drawn from that center to any point of its circumference. So let's draw one from the center to this point where the rectangle touches, where the corner of the rectangle touches the circumference of the circle. And let's call the radius small r. Then let's draw two other radii. One from the center to the point of tangency with this side of this quadrilateral that this circle is in, which is a square. So this square that this circle is in, it's a square because the diameter of the circle vertically and horizontally is still the same. The diameter of the circle is the same. So you know the diameter of the circle is the same length as this side and this side, this side and this side. So it's a square. So we're drawing one radius to the point of tangency between the circle and this side of the square. And we're drawing another radius from the center to this point of tangency between the circle and this side of the square. So looking at this rectangle, this small rectangle inside here, the length of the rectangle is 2 by 1. The length and breadth of the rectangle 2 by 1. So you can see clearly that if I section this part, then this is 2. From here to here is 2. Then from here to here should be r minus 2, since the entire length here is the same thing as the radius r. So if this part is 2, then this should be r minus 2, and the same thing at this place. If this length here is 1, then the length here will be r minus 1, since this is also r, and since here is 1, then the remaining will be r minus 1. So we have something that looks like a right angle triangle. So let's take this. You can see that we've taken this right angle triangle and we know that the length here is the same thing as the length here. The length from here to here is the same thing as the length from here to here, which is r minus 2. Then the length from here to here is r minus 1. So we have this right angle triangle. Then we're going to make use of Pythagoras theorem to relate all the sides. So since this is the hypotenuse opposite the 90-degree angle, then by Pythagoras theorem, r square will be equal to the sum of the square of the other two sides, which should be this. Then we have, expanding this, we have r square minus 2r minus or plus 1 plus r square minus 4r plus 4. So r square will be equal to, if you collect like terms, you have 2r square, you have minus 6r, then you have plus 5. Then if you bring this one over here, it becomes 0 equal to r squared. When this one comes here, 2r squared minus r squared. We'll be left with r squared minus 6r plus 5. Alright, so let's factorize that. So we have simple factorization. This constant value that doesn't have the variable multiplied by this term that has the variable to power 2, that's the variable squared, to give us 5r squared. Then factors of 5r squared that would sum up to give us minus 6r. We have minus 5r and minus r. Alright, minus 5r minus r plus 5. So minus 5r times minus r will give us 5r squared. Then minus 5r minus r will give us minus 6r. So pairing them up, we'll have r, then r minus 5, then we'll have minus 1 r minus 5. So we'll now have r minus 1, then r minus 5. So what we have is r minus 1 equal to 0 or r minus 5 equal to 0. So r is equal to 1 or r is equal to 5. Alright, we know that looking at this r minus 2 and r minus 1 here, r cannot be 1 because to be giving us a negative side. One, replacing the value of r here, now you have 1 minus 2, which is minus 1, then 1 minus 1, which is 0. Now you cannot have a negative side or a 0 side, so this one we would leave out and use this, because this one is going to be consistent with the values we require for the sides of the triangle. So we have r equals to 5. So our actual question is asking us to find the area of the green circle. So since we have the radius of the green circle 5, then the area of the green circle equal to the area of the circle is pi r squared. So we have pi 5 squared, and that will be 25 pi. Then if we want to express it not in terms of pi, then we have 25 times 22 should give us 550. Then 7 and 550 should be 7 and 550 should be 7. 7 and 55 is 7. Remember that's 6. 7 and 60 is 8. And that's remember 4. So 0.5 7. So approximately 17.57. So that's the area of the green circle.